Imagine a world where we had no way to measure or compare our achievements. How would we know if we're making progress? How would we determine the effectiveness of our methods or approaches? This same concept applies to the realm of unsupervised machine learning. Without evaluation metrics, we'd be navigating through a maze of complex data without a compass, left to guess if the patterns we're finding hold any real value. Speaking of mazes and patterns, let's dive into the world of clustering algorithms. A popular evaluation metric here is the silhouette coefficient. This metric calculates the mean distance between a sample and all other points in the same cluster, and then compares it to the mean distance between that sample and all points in the nearest cluster. The result is a score between -1 and 1. A high silhouette coefficient indicates that our samples are well clustered and that each cluster is well separated. On the other hand, there's the Davies-Bouldin index. Instead of looking at the distance between clusters, this index measures the similarity between clusters. The lower the Davies-Bouldin index, the better. It means that clusters are farther apart from each other and less similar. However, one downside of this metric is that it assumes clusters are convex and isotropic, which is not always the case in real-world datasets. While we have been talking about clustering, let's not forget about another significant area of unsupervised learning: dimensionality reduction. Here, we have metrics like the reconstruction error. This measures the difference between the original data and the reconstructed data after dimensionality reduction. A lower reconstruction error means that the dimensionality reduction algorithm has done a good job of preserving the important features of the data. In the vast landscape of unsupervised machine learning, these are just a few examples of the metrics we use to evaluate our models. Each has its strengths and weaknesses, and there is no one-size-fits-all solution. It's like choosing the right tool for the job. You wouldn't use a hammer to screw in a bolt, would you? So what have we learned today? Evaluation metrics are indispensable in the world of unsupervised machine learning. They guide us through the intricate maze of data, helping to validate the patterns we uncover and measure the performance of our models. They are the yardstick by which we measure our progress and the compass that keeps us on track. From the silhouette coefficient and Davies-Bouldin index used in clustering to the reconstruction error in dimensionality reduction, each metric offers unique insights into the performance of our models. But remember, choosing the right metric depends on the task at hand and the nature of your data. It's all about using the right tool for the job. In the world of unsupervised learning, we are explorers charting unknown territories. And as we venture further into this exciting realm, our evaluation metrics are the compass and map that guide us, ensuring we're on the right path, making meaningful discoveries, and continuously advancing in our journey. After all, what's an exploration without a way to measure our progress?